As participants in the OGC Vector Tiles pilot, at Ecere we have developed and integrated additional functionality to our Gnosis geospatial software to make it more interoperable with other software leveraging vector tiles. Improvements were made and capabilities were added to both our map server as well as our client and visualization components. Major additions included implementing support for the widely used Mapbox vector tile specifications, as well as producing and displaying GeoPackage contents making use of vector tiles extensions. Our implementation of WMTS, the OGC Web Map Tile Service, now offers additional possibilities in terms of vector output formats. In addition to the GML, GeoJSON, GeoEcon, and Gnosis map tiles formats previously supported, it is now possible to access tiled vector data using the Google Protocol buffers encoding described by the Mapbox vector tile specifications. As before, our service is able to retile vector data on the fly to a number of tiling schemes, including the one compatible with Google Maps based on a pseudo-Mercator projection widely used together with Mapbox vector tiles. Our WMTS client was improved to support vector tiles, including all of the encodings served from our WMTS service. As WMTS already provides a mechanism to describe tiling schemes and uniquely identify a particular tile, vector tile extensions for it are rather straightforward. As demonstrated here with this visualization of the DARA datasets, interoperability was also tested with the different services with both Mapbox and GeoJSON vector tiles. However, WMTS covers little of the extra functionality and flexibility that vector data can provide. This is why the pilot also looked at vector tiles extensions for WFS, the web feature service, which offers a lot more capabilities specific to vector data. Again, interoperability was tested with both our new WFS3 service as well as those of the other participants in the pilot. During this pilot, the participants designed vector tiles extensions for the WFS 3.0 specifications, which themselves are still under development. We implemented those in both our service and the client software. In addition to serving and accessing vector tiles layers, we tried to stress the fact that many notions such as tiling, coordinate reference systems, geospatial, and temporal extents apply the same whether the data consists of vector, coverage, or imagery. We think that going forward, both users and developers would greatly benefit from a harmonized map service which would regroup the common capabilities in a single API regardless of the type of geospatial data. Layers of different types, for example, the elevation, imagery, and street maps, could easily be accessed from a single service and endpoint. Rather than coming up with a new version of each different service standard, at Ecere we are of the opinion that the WFS3 and next generation services approach would be a perfect opportunity to achieve this harmonization of OGC services. Finally, we looked at GeoPackage as a means of transmitting and storing tile vector data. GeoPackages are convenient as a self-contained bundle of geospatial information and are especially useful in low bandwidth and disconnected environments. First, we implemented support for producing GeoPackages from our GIS tool, offering a number of different options. Extensions for storing vector tiles within GeoPackages were implemented, including the option to either embed attributes information within the individual tiles themselves or within an attributes table in the GeoPackage, as normally done for storing non-tiled vector data. The advantage of the attributes table approach is to avoid repeating the same information for features which occur in many different tiles, as well as the ability to perform SQL queries, potentially together with the R-tree extension for spatial indexing. A selection of supported encodings is provided, including among others Mapbox vector tiles, GeoJSON, as well as our Gnosis map tiles format. It is also possible to select whether multiple layers should be encoded as a single Mapbox vector tile set with multiple layers in each encoded tile, or using a separate tile set per layer. When tiling the data, we offer a choice of tiling schemes based on WMTS well-known scale sets, including the one compatible with Google Maps, but also our own Gnosis global grid, which has the particularity of featuring fewer tiles closer to the pole than at the equator. The description of our less regular tiling scheme is something we hope a future OGC-wide tiling scheme description standard will enable, both in GeoPackage as well as through WMTS and WFS3. We tested our visualization capabilities of vector tiles stored within GeoPackage with the GeoPackages we produced ourselves, but also with those produced by other participants. Tile data, whether raster or vector, provide a lot of benefits to geospatial and web mapping applications in terms of performance, low bandwidth usage, and responsiveness. Although tiling introduces some added complexity, this complexity would normally be handled by the underlying software, and users should be oblivious to the fact that tiles are in use. The ability to define and include styles within the GeoPackage, which can be based in part on the attributes associated with the data, was also implemented. The same type of capability can be implemented as well for WFS and WMTS using a getStyles request. More work on styling will likely be done in a future phase of the vector tiles pilot. Although the data here has been tiled and encoded according to Mapbox vector tile specifications, we show here that its vector nature is still intact as we recombine the features together. We can perform basic measurements and analytics, editing, and anything else that can be done with non-tiled vector data. To avoid drawing undesired edges of polygons at tile boundaries, Mapbox vector tiles rely on letting the data extend beyond that of the tile's extent. Our Gnosis map tiles encoding opts instead for marking segments artificially introduced when clipping polygons to a tile boundary, thus facilitating the recombination of tiles into whole features for purposes other than visualization. Both approaches can be used with GeoJSON or GML vector tiles, and more interoperability work should be done so that both approaches are usable with a mechanism for selecting a specific approach.